All right, here's an example of an arc length one. They want you to find what's the length of a cardioid shown here. That's given by 1 plus sine theta from 0 to 2 pi. Well, we just looked at how to do this. Your length is going to be the integral from a to b of the square root of r squared plus dr d theta squared, integrating about our angle here. So we know our r equations right here. What is dr d theta? We can do that quick. That's our derivative up here with respect to theta. So the left side would just be dr d theta. On the right side, we got derivative 1 is 0. Derivative of sine would be cosine theta. So now let's integrate this. We'd integrate it from 0 to 2 pi of the square root. Our r equation is 1 plus sine theta squared. And our dr d theta is cosine theta squared. And we'd want to do this. Now, if this was an FRQ, most of the time these ones are not going to be easy ones to actually go through by hand. So most of the time they are going to be in the calculator section. If this was a non-calculator one on the MCQ, they might have this as a simplified one. So one thing to watch for, we could do a little bit of simplifying on this if they were just asking you to match it to an equivalent one. If we squared 1 plus sine theta, meaning multiply 1 sine theta times another 1 plus sine theta and multiply that out, what you'd get here is 1 times 1 is 1. 1 times sine theta, another 1 times theta would be 2 sine theta, and then sine squared, sine times sine is sine squared. And this will simplify a little bit using some of our Pythagorean identities here, because we know sine squared plus cosine squared would be equal to 1. So if it was a matching one on the AP test, know that that would then be equivalent to 1. So another way of writing this would be, if this is equal to 1 and we got another 1 over there, that would be the same as 2 plus 2 sine theta d theta. So it might be a matching one where you'd have to then select that. Otherwise, use your calculator here to do that integral. So if we go math, integral here, we're integrating from 0 to 2 pi. I'm going to put the simplified one in here, so make sure you get the square root in there. Square root of 2 plus 2 sine theta. Make sure you're in radians when you do this. And we got to do one last thing, get that last theta in there. And it looks like this one's going to evaluate to 8. So the length around that cardioid is 8.